Okay, well this is going to be Chapter 10 for the Netacad CCNA Course 1 for the version 5 software, or the version 5 of the material for the CCNA course. If you're looking for the 5.1 version of the material, it is there's a link to the playlist down in the comments below, or the description below, excuse me. So my name is Jason Johnson. Thank you for watching this video. If you find anything helpful, or if you want to be updated on future videos, click the subscribe button below and share with others if you feel that you found it helpful. If you want to leave a comment, I will see that if you have any questions, and I'll get back to you as quick as possible. Okay, let's take a look at the application layer for Introduction to Networks. By the end of this chapter, or by the end of this material chapter, you should be able to explain the functions of the application layer, the session layer, and the presentation layer, and how they work together. Describe how common application layer protocols interact with end user applications. Describe at a high level common application layer protocols, and that at a high level. You don't need to get into fine-grained detail in this course, but you're going to need to do that at a high level, and how those protocols provide internet services to end users, including the www service and email. Describe application layer protocols that provide IP addressing, such as DNS and DHCP, and describe features of the well-known application layer, such as FTP, file sharing, and SMB protocol, and explain how data is moved across the network from opening an application to receiving the data. So, application layer protocols. When we're looking at the OSI model versus the TCP/IP model, there are key parallels in the transport and the network layer. The transport and the network layer here. And then when we get up into the OSI model for session, presentation, and application, these three layers here are combined into one application layer on the TCP/IP model. When we're looking at these layers here, either 5, 6, and 7 on the OSI or the application layer for the TCP/IP, these are the protocols that are being taken care of. The domain name system, or DNS, hypertext transfer protocol, or HTTPS, your web pages, your mail protocol, POP mail, DHCP, which is assigned your IP addressing, file transfer protocol, how you transfer files using that protocol, and internet messaging access protocol. So these are all handled at the application layer for the TCP/IP model, and session, presentation, and application layer at the OSI model. Okay, so when we're looking at the presentation and session layers here, the presentation layer is responsible for the coding and conversion of the application layer data, and the data compression, and any encryption for the transmission and the decryption of data sent by the destination. And then the session layer functions, creates, and maintains dialogue between source and destination applications. And it also handles the exchange of information to initiate dialogues and keep them active during starts, or to restart sessions. At the presentation layer, on the OSI model, on the presentation layer, and on the application layer, this is where we see programs such as QuickTime, MPEG, GIF files, graphics interchange format, or GIF files, joint Photoshop or JPEG files, or PNG files. So pictures, movies, GIF files, those are all in the application layer here. Now at the application layer protocols that we use, DNS is one that's used to resolve internet name to IP addresses, so that if you have a like google.com or yahoo.com or amazon.com or jasonejohnson.com, a plug for my website there, that resolves that domain name, so we can type in a domain name into our web browser, and that resolves that to an IP address. So we don't essentially have to remember phone numbers. So when we use a plain old telephone system or a cell phone system, we have to dial a telephone number, and we have addresses in there, and we have an address book. Well, what the DNS system does is it creates an address book on the internet, so that we don't have to remember IP addresses. We can just type in a domain service, and then that gets resolved to the IP address. We also have Telnet. That's a terminal emulation protocol. You will use that if you get more into networking into computers, but most users using computers and networks don't use Telnet. Bootstrap protocol, that's a precursor to DHCP. Not used a lot anymore. It's used to obtain IP addresses during the boot up, but now we use DHCP. And DHCP is the dynamic host control protocol, and that's where we set aside a group of IP addresses that gets sent out to computers or devices that connect to a network so that they can have their own IP address. We don't have to manually go around and assign the IP addresses to all the devices, which when I first started working on computers, we did not have DHCP, and we had to manually go around and assign IP addresses to the different computers on the network. And we had a spreadsheet that listed out all the IP addresses, and then sometimes we would get those wrong and we'd have conflicts, and DHCP resolves all of that. And another protocol that we have is HTTP, which you're probably most familiar with and don't even realize that you're using it when you go into a web browser, but you're using the Hypertext Transfer Protocol. That's to transfer files that make up web pages on the World Wide Web. So the web is not the internet. The internet is all of this exchange of ones and zeros or exchange of information, and the web or HTTP is just a part of that. We also have FTP, which is File Transfer Protocol. File Transfer Protocol back in the early 90s when I was helping with a bulletin board system. We used FTP quite a bit. We had Kermit and some other different types of transfer protocols, but FTP was one of those. You also have a TFTP, which is a trivial that's used for connectionless active file transfer. You have SMTP, which is a simple mail transfer protocol. That's for transferring or sending mail messages. You have POP, which is Post Office Protocol, which is another protocol for transferring messages. And then you have IMAP, which is yet again another mail transfer protocol. So these three here are their primary ones to send mail messages back and forth between servers. Now, in the world of networking, a peer-to-peer network is where we just have two devices or some multiple devices, but we don't have any type of routing involved. We just have devices that are connected to each other, and they are processing information. So this computer may have files on it. This computer is requesting those files and then maybe sends them to the printer. Or this one sends the files over here to be printed. It goes to the print drivers. But both devices are considered equal in the communication. So the role of client and server are set on a per request basis. So both of these devices are both client and server depending upon what action they're performing at the time. So if peer 2 is requesting a file from peer 1, it's the client and this is the server. If peer 1 is wanting to print something to the printer that's connected to peer 2, then what would happen is peer 1 would send the file transfer over. It's the client at that point, and this is the print server, and then it would send it to the print server. So that client server relationship depends on what role is being performed at the time. Some of the peer-to-peer app functions would be client. You might have instant messenger going across a network, and you have two clients that are sending and receiving information back and forth, and that would be a peer-to-peer application that you would use, or an example of that. Some common peer-to-peer applications. These are maybe older, but these are file sharing that you would use in your system. BitTorrent, you might be familiar with BitTorrent. Bitcoin is another more popular word that you might, or name that you might hear on there. But those are file sharing or point-to-point or client sharing protocols, as you might call them, that we use where the two applications, you don't have a server involved. In the client-server role model, we have a server that hosts information, and then we have our clients that request that information. So in this example, we might have a web service. So we have our www service. It's put onto the network or the internet, and then these clients request file pages, and then those get downloaded. And that's a true server role that we have, and then we have a client role that's requesting information, and that server serves up that information. Now, when we're going to look at the well-known application layer protocols and services, these you're probably going to need to memorize or at least be very familiar with on the material for the CCNA exam. And if you're taking the NetAcad course, Course 1, which is what this material is for, it is going to be, or these are going to be on the exam, most likely on your final exam and on other quizzes. So you need to be very familiar with these. If you go on to take the Network Plus exam, And then when you get into Security Plus and you know with the CompTIA Network Plus, Security Plus, the A Plus, you need to know what these protocols are. So I would just recommend memorizing these so that you know. And you also want to memorize the ports that go with these. I mean, I know it doesn't have in this material here, but you want to memorize the ports that go with these. So HTTP, that's to browse the web. Port 80 or 443. Port 80 is if you're just connecting to regular web pages. 443 if you're connecting with encryption, but you want to know those ports that go with those. Simple Mail or SMTP, POP. HTTP, for example, you would put your address in here. That would get resolved to using DNS, and then the index.page pulls up. And this is the process here. You can go ahead and pause the video if you want to look at the steps here, but I'm not going to lecture on this. This is a basic web page that comes through. HTTP and HTTPS. HTTPS is your encryption layer, which means your data is encrypted. I would highly recommend using an app or an extension either for Firefox or Chrome called HTTPS Everywhere. You can get that from the Electronic Frontier Foundation, and you want to that's in either Firefox, Android, Chrome, or Opera. Now, in these next slides, I'm going to go rather quickly on these, and I'm not going to spend a lot of time describing each one of these other than just at a high level. You can pause the video so that you can read the data on here, but the differences between what HTTP and HTTPS does, whether it's either just standard data going through where everybody can read it or through it, whether it's encrypted. SMTP, POP, and IMAP typically use an application called a mail user agent, so something like Outlook, or if you have a Thunderbird client, those send and receive email messages. And that's an example there of it being routed through. SMTP and POP both work very similar. SMTP uses port 25. POP uses port 10. And you can see the differences here on those. And this is how it goes through the system here. Sends, goes to a mail transfer agent or a server. It has to have a server. And then it gets transferred and sent back and forth. And there's the back side, other side of it. The MDA accepts a piece of email from MTA, performs the delivery, and on to those steps there. SMTP transfers mail reliably. POP enables a workstation to retrieve mail from a mail server. And IMAP is unlike POP, where the user connects to an IMAP-capable server, copies of the message are downloaded, but the originals are kept on the server until they're deleted. DNS is how we resolve IP addresses to domain names. And we resolve a domain name to an IP address, and that allows us to have familiar names, for example, Cisco.com or JasonEJohnson.com, and that gets resolved to an IP address, so you don't have to remember that IP address. And that's very helpful when we go to the V6, and those are big, long hexadecimal numbers. You don't have to remember those numbers. You just have to resolve to that DNS. And those DNS servers set out on the internet, you register your domain. You register your domain and your IP addressing and where that gets pointed to. And then that DNS service resolves that for you. So we have a human legible name. It's resolved to a numeric network, whether it's either V6 or V4, but it gets resolved to an IP address. And then that can then be sent through. There's step 5. The DNS message format, you can pause the video here and read down through this. If you want to see your DNS cache or clear your DNS cache, you can do the ipconfig /display DNS or flush it /flush. If you do ipconfig and look at your different commands that are available to you on there in a command window. And on the Linux side, the same way, using the ifconfig. The DNS hierarchy, those are broken down. I'm not going to do a lot of lecturing here. You can go out and research these, but there's different hierarchies based upon the different extensions. For example, the US is .us, Australia is .au, Colombia, so forth. And then you have the .coms, which are commercial. .orgs are usually nonprofit, but they're not restricted. You can still get a .org even if you are nonprofit. In some cases, you just have to prove to the whoever's passing out the domain names at the time, or getting those. You have to prove that. So like a .edu, you're going to have to prove that you are in education. You're going to have to prove that you're in education, but you can get all kinds of different ones that are out there. .biz, .gov are usually governments inside of it. So you'll have a .gov.us or something along those lines in there. And then you have your secondary levels, which is your domain name, Cisco, Jason E. Johnson, Amazon, and then whether it's a .com or a .biz or a .org or a country, it'll be on there. And some countries sell their domain names. So like if you have a country like MD, I think it's Moldova, is .md. They sell domain names to doctors in the United States, medical doctors, and then so that they can buy their name .md at the end of it. But that's the country of Moldova is then selling their top level domain names information, so they can do that. So you can check that go out on the internet and check that out. NSLookup is a utility, and this is on the Windows side where you can do a lookup, and you can look up the default server and the address on there because that's public information, but it has to be able to resolve the DNS. So the NSLookup does that for you. DHCP allows a host to obtain an IP address dynamically, which means you don't have to do it. It just automatically gets signed out. You create your subnet and you tell it how many block of IP addresses that you want for that host range, and then if a client connects and says, "I need an IP address," it's going to send that out to it. And that's continuing on here. Again, you can pause on these slides as I get to them. I'm moving through these kind of rapidly. And here's the DHCP operation. A client would say, "I need a DHCP." The DHCP server says, "Okay, here's my IP address." And then it goes ahead and says, "Okay, I want to go ahead and request it now." And then it gives an acknowledgement. And then it holds that IP address until it reboots. Whether you clear it or the DHCP server becomes unavailable and clears itself because there's a time limit on how long those IP addresses get held. And so depending on one of those conditions are met, it'll hold that IP address. File transfer protocol, I'm not going to lecture on this, just let you read those. And then how it works there. SMB, server message block. Clients establish a long-term connection to the servers. This is so you can see printers. Usually printers isn't a good example of that. And this is an example of Windows. I know that's sort of hard to see there, but if you're looking at Windows, it holds that link in your Windows Explorer. Okay, so talking about the Internet of Things, all devices, or I say all devices, but a lot of devices now are getting IP addresses. For example, one example, and this is late 2016. This is 1st of December for 2016. And I'll give the example of a refrigerator in your home may have an IP address on it so it becomes a smart refrigerator, so that you can it can get messages. And I don't know why you would ever need Twitter or social media on your network or on your refrigerator, but that is what's happening. So devices, all types of devices now are going to be connected to the internet, from shopping to your cars to being able to do, even your clothing at some point. Maybe have your backpack have some type of way to connect. If phones are an example, but all types of devices are getting connected to the internet, and that's what we talk about, the Internet of Everything or Internet of Things. When you hear that, or the IoT, that's what in the Cisco world, what they're talking about, and on the internet as well. When you hear the Internet of Things, that's what they're talking about. Okay, so just a quick review. A message travels through a network. The application layer sends the stream. It goes down the OSI model in this case, the application transport, the internet that goes to network access, gets sent across, and then comes back up the layers on the other side. And I'm just going to scroll through these. You can pause these if you want to look at them, but I'm just going to scroll through them quickly. Well, quickly from my end. And then we get the right data to the right application. And when it gets through on the receiving end, depending upon the port number, depends, port 80 would be HTTP, and then our computer then knows how to interpret that as far as a web page goes. Okay, so for this chapter, we looked at services. We looked at protocols such as HTTP, SMTP, POP, IMAP. We looked at point-to-point applications, DNS, and then when all of those elements work together at the application layer on the TCP/IP layers, the TCP/IP model. Those all work together to be able to send information, whether we're using the OSI model or the TCP/IP model. Those protocols work. We can share web pages. We can send print jobs, and those all work through the. Let me scroll back up here. Those all work through the application layer. Pull that screen up there. There we go. Application layer on the TCP/IP model, or the layer session presentation application on the OSI model. Okay, well, this was chapter 10 for the CCNA course 1 for the 5.0 version of the material. If you look down in the description of this video, I'm going to have links to the 5.1 version of the software. And if you have any questions, you can leave a comment below. And thank you for watching.